Time for more algebra, because too much is never enough. Stoichiometry can sometimes feel like a swear word in chemistry, but if you take it slowly and follow it step by step, then after a bit of practice, it will start coming together. Now's about the time I suggest going to get some chocolate. It's performance enhancing. Let's start with a balanced equation. You can tell it's balanced because it already has the coefficients added out the front. 3 lots or moles of calcium chloride react with 2 moles of sodium phosphate to form 1 mole of calcium phosphate. Remember, if there's no coefficient, then it's just 1. And 6 moles of sodium chloride. We're going to work through an example in which you were told that you had, say, 200 grams of calcium chloride. That's all you've got, and you want to do this reaction and work out how much calcium phosphate you can make. Think of a balanced equation like a recipe. What would happen if you want to bake a cake and the recipe calls for 2 eggs, but you look in the fridge and there's only 1 egg left? You could scale your recipe down and make half as much. The same thing happens with chemical reactions. We just adjust everything to compensate for the amount that we have. The thing to remember is that everything must be scaled the same, all doubled or all tripled or all halved or whatever. If you change a recipe, you must change all the ingredients or it won't work. You can't use half the amount of flour for a cake but keep all the other ingredient amounts the same. It'll just end up a big mess and not turn out properly. So, looking back at our equation here, it says we need 3 moles of calcium chloride to do it. We have 200 grams. I have no idea if that is 3 moles or not, but luckily we have a formula that we know how to use that can convert the grams into moles. The first step in stoichiometry says that you must convert all grams to moles. We can do that using the formula N equals M divided by MW. To use this formula, we will first need to calculate the molecular weight for calcium chloride. So that's 1 calcium plus 2 chlorines. Never include the coefficient in these calculations. Looking up these elements on the periodic table, we can see that the molecular weight for calcium chloride is 1 lot of 40 plus 2 lots of 35.5. Chuck those numbers into your calculator and we get a molecular weight of 111. Now we can put this number back into the equation to get the number of moles. N equals 200 divided by 111, which gives me 1.8 moles. So we only have 1.8 moles of the calcium chloride, and the recipe's calling for 3, so we'll need to scale everything to adjust it for this amount. This is the tricky step, so eat some chocolate now. Step 2 is to look at the molar ratio, which just means look at the coefficients and their proportions. In this example, we want to know how much calcium phosphate we can make from 200 grams of calcium chloride, or 1.8 moles of calcium chloride. Looking back at our balanced equation, we can see that 3 moles of calcium chloride gives us 1 mole of calcium phosphate. So the ratio or proportion has to stay the same. 3 gives us 1. So the amount of calcium phosphate formed is always 1/3 of the amount of calcium chloride we put in. So if we only have 1.8 moles to put in, we will get 1/3 of that as calcium phosphate. 1/3 of 1.8 is 0.6, or you could just use your calculator to divide it by 3 if you like. So that's step 2 done. We now know that 1.8 moles of calcium chloride will give us 0.6 moles of calcium phosphate. But how much is 0.6 moles? Let's convert it to grams now so that it makes a bit more sense. Step 3 is converting back to grams. We use the same equation we've been using, but we put in our new numbers for the calcium phosphate. So, N equals M divided by MW again. But this time we know that the N is 0.6, so we can substitute that number in. We don't know the M this time, that's what we're trying to figure out. How much mass do we get? And the molecular weight isn't usually given to you, so grab your periodic table and your calculator and let's figure it out. In calcium phosphate, there are 3 calciums, 2 phosphoruses, and 8 oxygens. That gives us 3 times 40 plus 2 times 31 plus 8 times 16. Put it all in your calculator and it comes out as 310. So going back to our equation, we now insert 310 for the MW. 0.6 equals M divided by 310. To get the M, we need to rearrange it slightly. M is going to be 0.6 times 310, which is 186 grams. So, to sum it up, if we start off with 200 grams of calcium chloride, we'll end up with 186 grams of calcium phosphate. We'll also use up some sodium phosphate and make some sodium chloride, but we weren't as interested in that stuff, so we haven't bothered talking about it. As long as the equation's balanced first, we can just pick out the things we're interested in. So over to you. Practice definitely makes perfect with stoichiometry, and chocolate helps too.